Welcome to Chem Laboratory tutorial. Today we'll be looking at elevation of boiling point and depression of freezing point. In our previous video, we talked about colligative properties and the factors that affect colligative properties. And these factors include lowering of vapor pressure, depression of freezing point, elevation of boiling point, and osmotic pressure. So in our previous video, we have done example for lowering of vapor pressure. Now we are going to look at elevation of boiling point and depression of freezing point. What is elevation of boiling point? It talks about the magnitude difference of temperature between the vapor pressure of the solution and that of the solvent. And this elevation of boiling point is directly proportional to the molar concentration. So it means that for elevation of boiling point, delta T B, TB means boiling point of the solution. Change in the boiling point is equals to what? T2 minus T1. And we said the change in the elevation of boiling point is equals to what? KBN. That is why we said it is directly proportional to molarity. And what is the difference between molarity and molality? Molality talks about the number of moles of solute per the mass in kilogram of the solvent, which is quite different from molarity. So it means that delta B is gotten through the molar concentration constant, which is Kb, and molar concentration. So delta B can also be in this form, T2 minus T1 equals to KBN, where T2 becomes the temperature of the pure vapor pressure of the solvent, and T2 is equals to the vapor pressure of the solvent, and T1 is the temperature of the vapor pressure of the pure solvent. So this is for just solvent of the solution, while T1 is just what? For pure solvent. So we will take example of that. But before we take example, what is freezing point depression? Freezing point depression also talk about how vapor pressure are being reduced by what? Temperature. And this is just an opposite. The elevation of boiling point is an opposite of freezing point. What makes it different is that because freezing is at minus temperature, so we just simply put minus and change this TB to TF, and the same thing is applicable here, and we also put our minus here because both are directly proportional to molar concentration. So it means that the change also will be minus. When we put them into bracket, it will be minus, and thereafter the KB that was there will be changed to KF because we are talking about depression of freezing point. The same is applicable to this aspect, which is the molar constant for freezing point depression. Now we are going to take example how we can calculate the elevation of boiling point of a solution and also the freezing point of a solution. So let's look at the question together. Calculate the boiling point and the freezing point of a solution containing 478 grams of ethylene glycol in 3,202 grams of water. Meaning that ethylene glycol in this case is what? The solute, and water is the solvent. And we know in calculating boiling point, the formula is delta TB is equals to what? KBN, where this N is called molality. Molality. And how do we calculate molality? I told you in our previous video that molality is the number of moles of the solutes all over that of the solvent. Mass of solvents in kilogram. That is molality. So for us to calculate the boiling point of this vapor pressure of solution, how do we do it? We will first of all calculate the number of moles of the solutes. And how do we calculate number of moles? we said calculating number of moles is equals to mass in gram over molar mass. And therefore, we need to calculate the ethylene glycol. The structural formula for ethylene glycol calculate the molar masses now. So oxygen is 2 in the structure, so we simply say 16 times 2. How many hydrogen do we have? Hydrogen is 1, 2, 3, 4, 5, 6. So 6 times 1. Then carbon is 2, so we have 12 times 2. So when you add them together, you will have 32 plus 6 plus 24. So altogether, the molar mass of ethylene glycol becomes what? 62 gram per mole. 62 gram per mole. So we have calculated the molar mass of ethylene glycol. The next thing is to now calculate the number of moles of ethylene glycol. So number of moles of ethylene glycol is equal to mass in gram. The mass was given to us as 478. Mass 478 is the mass all over the molar mass, gram per mole. So you see that the gram will cancel gram, we are left with what? Mole. So it means the answer will be what? 7.71 moles. So that is the number of moles of ethylene glycol. We've gotten the number of moles to be 7.71 mole of ethylene glycol. Now that we have gotten that, the next step is to now calculate the mass of solvent in kilogram. And how do you calculate the mass of solvent in kilogram? What is the solvent? The solvent is water. And the mass given to us in water is in gram. So you're only just to convert it to kilogram. And converting it to kilogram means you are dividing by 1000. So we've gotten that the number of moles of glycol. Now dividing this by 1000, we get the solvent in kilogram. So that means 3202 gram divided by 1000 is equals to mass of solvent in kilogram. So now that we have done that, it means we will now put this into the formula. We will calculate for molality. And how do we calculate for molality? We have gotten the number of moles, we have gotten the mass in kilogram, is to impute the parameters. Molality will now be equal to 7.71 mole all over 7.71 mole of ethylene glycol all over 3.202 kilogram of water. That means molality is equals to 2.41. That is molality. And what is the unit of molality? Degree per mole. So that is that for molality. So now that we have gotten molality, now you will put this Kb, like I said, is a constant boiling point of water, and that value is 0.51. So we say change in the elevation of boiling point is equals to 2.41 times 0.51 degrees Celsius. 0.51, and therefore we have 1.23 degrees Celsius. So it means the boiling point was elevated by what? 1.23 degrees Celsius. Same is applicable to freezing point. So do that of freezing point, send your answer to the comment section and keep on watching liking and commenting. Please don't forget to subscribe.